All right, forget every vacation spot, every dream destination you've ever had on your list. Today, we are taking the ultimate one-way trip to the most extreme place in the entire universe. Now, it's not going to be comfortable, but the physics, oh, it is beyond fascinating. We are going to travel inside a black hole.
So, what would happen? I mean, really, what would you see? What would you feel as you fell into one of these cosmic monsters? It is the ultimate journey with no return ticket, and the science behind it, well, it's way stranger than any sci-fi movie you've ever seen. Before we even take our first step, let's just, skip to the end, shall we? This is where our journey terminates, spaghettification. It's a brutally honest and kind of horrifying term for what happens when gravity decides to stretch you into a long, thin strand of cosmic pasta. It's not a great ending. But the journey to get there? That's where things get really, really weird. So let's rewind. Before we get anywhere near that gruesome finale, let's start from a safe distance. Because even out here, the universe around the black holes starts to look wrong. The very fabric of space and time is beginning to bend and warp around it. Here's the basic idea, right? Immense gravity bends light. I mean, even our own sun does this a tiny bit, making the stars behind it look like they've shifted just a little. But a black hole, with its insane density, it takes that concept and cranks it up to a mind-bending extreme, smearing and smudging the cosmos like a wet painting.
Now this is where it gets really trippy. If the alignment is just right, say a distant galaxy is perfectly behind the black hole from your point of view, that galaxy's light gets smeared into what's called an Einstein ring. You're not looking at a ring-shaped object. No, you are seeing the light from a totally normal galaxy being warped into a perfect glowing circle.
Okay, we're getting closer now. We've just hit a critical boundary, the photon sphere. This isn't science fiction, it's just physics at its most extreme. Right here, gravity is so perfectly, intensely balanced that particles of light, photons, are trapped. They can't escape, but they haven't been pulled in yet either. They're literally forced to orbit the black hole, maybe forever.
And this just breaks your brain a little. If you could somehow just pause right here in the photon sphere and look to your side, the light from the back of your head would travel all the way around the black hole and come right back to your eyes. You would literally see the back of your own head. Just think about that for a second.
As incredible as that is, we can't hang out here. We have to keep going, pushing forward toward the most famous part of a black hole, that one boundary you can never, ever uncross. And this is where reality just kind of splits in two. For someone watching you from way back in the safety of their spaceship, time itself would seem to warp. Your approach would get slower and slower and slower until you appear to freeze right at the edge. The light from you would stretch out and get redder, and then you'd just fade away. They would never see you cross. But for you, everything feels fine. You just sail right past this invisible line without even noticing. And that invisible line, that's it. That's the event horizon. The second you cross it, your fate is completely sealed. The gravitational pull is now so powerful that nothing, not even light itself, can escape. There is no turning back. Your fall to the center is now absolutely inevitable. So, you did it. You crossed the boundary. You're officially inside a black hole. What happens now? What does it actually feel like in these final moments? You know what's pretty wild is that if you picked a really, really big, supermassive black hole, the first part of your fall might actually be kind of peaceful. The tidal forces aren't that extreme right away. You could have hours just floating in the darkness, knowing your end is coming, but not feeling it. Not yet. And as you fall deeper and deeper, your last link to home begins to change. The entire universe you left behind would look like it's being squeezed into a smaller and smaller and brighter dot of light behind you. It's one final bizarre window to, well, everything that ever was. This is where the calm part of our trip, well, it ends abruptly. See, the problem is the gravitational pull isn't the same across your body. The pull on your feet, which are just a tiny bit closer to the center, becomes exponentially stronger than the pull on your head. And the result of that insane gravitational difference is the word we started with, spaghettification. Your body would be stretched longer and thinner, and ultimately your very molecules would be violently torn apart. It's a brutal, but thankfully, probably very quick end to our little journey.
So, your atoms have now reached the singularity, this point of infinite density, where our entire understanding of physics just stops. But what is it? What happens there? Well, this is where science moves into some pretty fascinating theories. One of the wildest ideas out there is that maybe, just maybe, a spinning black hole isn't a dead end. Could it, theoretically, create some kind of an escape route? Maybe a bridge through space-time itself? It's a concept you've probably heard of. A wormhole. The easiest way to think about it is with a simple piece of paper. Imagine you want to get from one point on the paper to another. Sure, you could travel the long way across the surface. Or you could just fold the paper in half and poke a hole through, bringing the 2 points right next to each other. A wormhole, in theory, does that with the very fabric of the universe. Now, that wormhole escape, it's a fantastic idea, but it is still pure theory. So let's pull back from the edge of that black hole for a second. Because after this terrifying journey into a black hole, there's a really profound truth about your own place in the cosmos that is just as mind-bending. It all comes down to this really fundamental idea in physics called the cosmological principle. It basically states that on a large enough scale, the universe is the same everywhere. And a huge consequence of this is that everything appears to be expanding away from you, no matter where you are. And the classic way to picture this is with a balloon. But here's the trick. Don't think of our universe as the inside of the balloon. Think of it as just the two-dimensional surface. Now, as you inflate it, every single dot on that surface moves away from every other dot. And here's the key part. If you were standing on any one of those dots, it would look like you are the center of everything, that all the other dots are rushing away from you. But there is no single center on the surface.
And that brings us to this final, absolutely incredible takeaway. Because of the way the universe is expanding, from your specific point of view, right here, right now, everything is moving away from you. So no matter where you are or who you are, you really scientifically are the center of your observable universe. The only question left is, what are you going to do with that information?